Let's do example 4. Find the derivative of this function. First, I want you to look at this function and know that the function is implicitly defined. So to find its derivative, we have to take the derivative of both sides and solve for y prime. Okay, so I'm not going to write down these two steps. We're just going to do it. So take the derivative of the left side and then take the derivative of the right side. So take the derivative of both sides. So that's what we mean. Now the derivative of this guy, kind of similar to the chain rule that we did earlier, guys. There's an outside function, which is parentheses raised to the third. And then there's an inside function, which is the function y. So its derivative is going to be 3y squared times y prime minus. Now, when you take the derivative of this guy, it's a product. So you have to use the product rule. And the product rule says that take the derivative of the first, so the derivative of the first times the second function plus the derivative of the second function. The derivative of y is represented by y prime times the first function. And then the derivative of a constant over here on the right side is 0. So now what we're going to do is we're going to distribute, and then we're going to distribute, and then we are going to solve for y prime. To solve for y prime, first you need to combine these. You have to I'm going to move the y to the right side. And then they have a y prime in common. So I factor out a y prime, and I have 3y squared minus x left equals to y. And then to solve for y, I divide both sides by 3y squared minus x. 3y squared minus x. So these will go away. So y prime is equal to y over 3y squared minus x. And that's the derivative function. Now, usually for implicitly defined function, in order to know the derivative or slope at a point on the graph, you really need to provide an ordered pair instead of just the x value, because the derivative function involves an x value and a y value, just like this one. Okay, awesome. Make sure you understand how to take the derivative of y cubed. That's very important to know. And if you have forgotten or still confused, refer back to example 3, because I show you how to find the derivative of y squared. Okay, good. Fine. Okay, so once again, here it is, another implicitly defined function. Let's find its derivative. So I'm going to start by taking the derivative of both sides like this. Okay, oops, forgot to take the derivative of the right side as well. The derivative of ln of x is 1 over x. Now, you have to apply the chain rule to this problem, okay, to this thing. So your outside function is the function ln, that. Your inside function is the function squared, and then you have your smaller inside, which is the function y. All right, so it's the chain rule that you gotta apply here. Now the derivative of, so start by taking the derivative of the outside function, which is 1 over whatever is inside, which is that, times this inside, which is going to be 2y, right? And then multiply that with the derivative of the inside one more time, the smaller inside, y prime. And then over here we know that that's 0. Okay, that might not be easy, so take your time and break it up into the chain rule properly. I can cancel that out with one of those. So here's what I have left. I would have y prime, 2y prime over y equals to 0. Okay, I'm gonna solve for y prime by first moving this guy to the right. So subtract 1 over x to both sides. You have this left, right? And then multiply both sides by y. Multiply both sides by y like this, so that these can cancel out. You got 2y prime equals to negative y over x, and then divide both sides by 2. And if you divide both sides by 2, you're gonna get this. That's the derivative function of this function, which is defined implicitly. All right, very good, very good. All right, let's do a harder one. Consider the equation. Find the derivative. Under what conditions on x or y is the tangent line to the curve horizontal, vertical? All right, so we got a couple things we have to answer. So first, let's take the derivative. I will start by taking the derivative of the left side, and then take the derivative of the right side. The derivative of x squared is 2x. We just use the power rule for that. Bring down the 2, subtract that by 1. The derivative of y squared, we have to use the chain rule for this. Bring down the 2, subtract the original power by 1, and then multiply that with the derivative of the inside, which is the derivative of y, and that's y prime, minus 4, the derivative of 4x is 4, plus the derivative of 7y is 7y prime, that's it. And then this one equals to 0. We can clearly, we'll be doing something to those guys, but first, because we want to solve for y prime, that's how we find the derivative, by solving for y prime. That's the next step. Okay, don't forget that. Look over here, we take the derivative of both sides, then we solve for y prime. I underline those because those two terms contain y prime, so leave those two terms alone for now. Go ahead and move these two terms to the right. So here's what we're gonna get. Oops, 2y times y prime plus 7y prime equals to negative 2x plus 4. Fact out with y prime, and then divide both sides by whatever you just factored out. Negative 2x plus 4 over 2y plus 7. Okay, awesome. Okay, so this is your slope function. Now, when is it horizontal? So horizontal, when is, at what x value, under what conditions of x and or y is the tangent line to the curve horizontal? Well, first of all, horizontal means that the derivative equals to 0. That's when the tangent line is horizontal. And this is true when the top, which is the numerator, equals to 0. So when this equals to 0, right here, guys, then the derivative equals to 0, because if that equals to 0, then 0 divided by anything is 0. Okay, so by looking at this, we can use common sense to conclude that when x equals to 2, the top is 0, because when x equals to 2, you're going to get negative 4, and negative 4 plus 4 is 0. Okay, so that's right. That's the answer. X equals to 2. When is this true? It's true when x equals to 2. But let's say if you want to systematically solve it, how do you show that x equals to 2? Well, what you want to do is you want to solve this statement right here. So this is true when the top equals to 0. So you take the top, and then you set it equal to 0, and then you subtract 4 to both sides. So you have 2x equals to negative 4, and therefore x equals to 2. I told you. See? So you can either show it systematically, or you can just use your common sense. Okay? Now, vertical asymptotes. Vertical tangent. That means that y prime is undefined. Okay? And true when the bottom equals to 0, right? Because the bottom can't be 0. The bottom 0 means that the function is undefined. So we take the bottom and we set it equals 0, and we ask ourselves, for what y value is the bottom equals to 0? Divide both sides by 2, and we get negative 7 over 2. So when y equals to negative 7 over 2, and that's when the derivative equals to 0. I'm sorry, that's when the derivative is undefined, because that's what we're looking for. We're looking for vertical tangent line, and undefined means vertical tangent line. Last problem. Consider the equation x squared plus y squared equals 25. Find the equation of the tangent line at the point x equals to 4. Are there any point where the slope is undefined? Start by finding the derivative. So derivative x squared plus y squared equals 2. So what I'm doing here is I'm taking the derivative of both sides. 2x plus 2y times y prime. From now on, I want you to look at that and be able to see that there's a chain rule built in, and then you quickly do it without showing the work. But if you are still working on the chain rule, then definitely show the work, because that's going to be helpful. Now, I'm going to solve for y prime. But here's the cool thing. I know that each of these terms has a 2, and because I can divide both sides by 2, that basically means that I can easily get rid of that factor of 2. And now, since I'm solving for y prime, I'm going to move the x to the right, like this, and then divide both sides by y. So there you have it. This is my derivative function for this implicitly defined function, which is the equation of a circle. Find the equation of the tangent line at the point x equals to 4. So at x equals to 4, in order for us to find the slope, we need the y value as well. So when x equals to 4, we plug that in here, and we find the y value. So if I were to plug 4 in there, then I am gonna get 16. And if I subtract that to the right, then I get 9. So guess what? I'm gonna have, so maybe on the side over here, when x equals to 4, y squared equals to 25 minus 16. So y squared equals to 9. Okay, and that means that y could either be 3 or negative 3. So guess what? I got 2 possibilities. Y could either be 3 or y could either be negative 3. So I got at x equals to 4, I got 2 points that I'm working with. So let's say the first point, the slope is, remember, the slope can be found by plugging x and y into here. So the slope is gonna be negative 4 over 3. All right. For this second point, the slope is gonna be 4/3, all right? And we have all the ingredients we need. Now we just have to put it together. So y minus y1 equals to m times x minus x1. Same thing over here. Y minus y1 equals to m times x minus x1. And we're done. Oh, we're not done. We're done with part A, but we need to do part B. Are there any point where the slope is undefined? When we look at this graph, when we look at this derivative function, we can answer part B because undefined means that the bottom is 0. The bottom is 0, right? So, part B, yes, y equals to 0. Okay, but remember they're asking for points. So when y equals to 0, what are the x coordinates? So yes, y equals to 0, and if you plug 0 back into this function, then you have this left as your x. That means that x could be 5 or -5. So there are actually 2 points where the slope is undefined. Those points are 5, 0 and -5, 0, which kind of makes sense because if you look back at this graph right here, this is just a smaller an alternative version of the equation of a circle, but instead of having a radius of 5, the radius is the square root of that number. This one has a radius of 4. So at this point right here, when 5, 0 and then -5, 0, that's where the graph has vertical tangent line or undefined, or the slope is undefined. So there you go.